So now I will be discussing the introduction of logic and statements, and after that I am going to define between the logic and statements. So here we are. Let's start with the introduction. In math, the logic statements can involve just words and symbols together, or just symbols. A logic proposition is simply a statement that can be labeled as either or true or false. You use critical thinking to make new connection based on what you know to be true. So, critical thinking is important not just in everyday life, not just in mathematics pala, but in everyday life. Have you ever heard someone make a statement and then thought, wait, it is just true? Or it is that true? Sometimes people have reasons for thinking something is true even though it's not. Determining if a statement is true is a great skill to have. When determining if a statement is true, most people start by looking for examples, which are situations for which the statement does turn out to be true. Logic is the study of criteria used in evaluating inferences or arguments. An inference is a process of reasoning in which a new belief is formed on the basis or a virtue of evidence or proof supposed provided by the other beliefs. An argument is a collection of statements or propositions, some of which are intended to provide support or evidence in favor of one of the others. I am going to define what is logic and statement in simple words. In simple words, logic is the study of correct reasoning, especially regarding making inferences. Logic began as a philosophical term and is now used in other disciplines like mathematics and computer science. While a statement is a sentence that either true or false.
Okay, after defining the two words which is logic and statement, now let's talk about the meaning of both words when it comes together. Okay, so logic's statement. In logic, the term statement is variously understood to mean either a meaningful declarative sentence that is true or false, or a proposition. Okay? So in math, logic statement can involve just words and symbols, or just symbols. A logical statement is a statement that when it's true, it allows us to take known set of facts and infer or assume a new fact from them. Logical statements have two parts. Okay? So, one is hypothesis, which is the premise or set of facts that we start with, and second one is the conclusion. Conclusion, which is the new fact that we can infer when the hypothesis is true. Okay, so let me give you one example of a logical statement, and let us identify the hypothesis and the conclusion. Okay, for example, if you go outside without any rain gear or cover, when it's pouring rain, you will get wet. Okay, so our hypothesis in this logical statement would be, if you you go outside without any rain gear or cover when it's pouring rain. That would be our hypothesis. Okay? Remember that the hypothesis must be completely true before we can use the statement to infer anything new from it. Okay? Okay. What this statement says about someone who doesn't go outside, about someone who uses an umbrella, about what happened to someone when it's not pouring rain. Okay? Nothing. So, this statement doesn't apply to anyone in those cases. Okay? So, our conclusion would be you will get wet. Okay? Suppose it's raining and someone walks outside and doesn't have any rain gear or other kind of cover. What will happen? Okay, so all the parts of the hypothesis have been met. So, if the statement is true, we can infer that the person is going to get wet. It certainly seems reasonable, but they would. Okay. Note that in this example, if the hypothesis isn't true, the person still could get wet. Okay, for example, on a sunny day with no rain, someone might go outside to clean up his cart and get sprayed uh, by hose. Someone else might go swimming and then they would really get wet. So, okay, the statement says nothing when the hypothesis is false. It's only helpful when the hypothesis is true. Okay? And always remember that every language contains different types of sentences, such as statements, questions, and commands. So it is important for you to know, for you to be able to recognize what kind of statements are present. For example, um, the statement, is the test today? Is the test today? Is as example of a question. Okay, so go get the newspaper is a command. This is a nice car is example of a opinion. And Denver is the capital of Colorado. So that is statement is true. Now, let me introduce the person behind this concept. Okay. So, first, we have Gottfried Wilhelm Leibniz. Okay. He is a German polymath active as a mathematician, philosopher, scientist, and diplomat. Okay. He is the first mathematician to make serious study of symbolic logic. Okay. So, Leibniz tried to advance the study of logic from a merely philosophical subject to a formal mathematical subject. Okay. And next one would be George Boole. Okay. He is English, mathematician, philosopher, and a logician. Okay. He is a founder of the algebraic tradition in logic. He helps to establish modern symbolic logic and whose algebra of logic, now called Boolean algebra. Boolean algebra is a basic to the design of digital computer circuits. Next one is Charles Dawson, one of the best-known logicians. His mathematical works includes a syllabus of plain algebraical geometry, the Fifth Book of Euclid treated algebraically, and the symbol of logic. And that is the logical statement. Thank you.
Simple statement and compound statement. A simple statement is a statement that convey a single idea. A compound statement is a statement that convey two or more idea. Connecting simple statement within a precise such as and, or, if then, and, if and only if create a compound statement. For example, I will attend the meeting, meaning simple statement siya. Kasi isa lang yung ideya na ipinapakita niya sa atin, hindi kagaya ng compound statement. It is composed of two simple statements. For example, I will attend the meeting or I will go to school. The word or is a connective for the two simple statements. George Paul used symbols such as PQR and to represent statement, and the symbols was the first to create symbols. These symbols is and, these symbols is or, these symbols is not, arrow is if then, right and left side of arrow if and only if.
Logic, compound, and symbols. Statements. Not P. Connective, not. Symbols form P. Type of statements, negation. Statements. P and Q. Connective, and. Symbols form P and Q. Type of statements, conjunction. Statements. P or Q. Connective, or. Symbol forms P or Q. Type of statement, disjunction. Statement. If P and Q. Connective, if and then. Symbols form P, if or then Q. Type of statements, conditional. Statements. P, if and only if Q. Connective, if and only if. Symbols form P and only if Q. Type of statements, biconditional. The negation of the statement today is Friday is the statement today is not Friday. In symbolic logic, the tilde symbols is used to denote a negation of a statement. If a statement P is true, its negation P is false. And if a statement P is false, its negation P is true. Here are some examples. Write the negation of a statement. Ellie Goulding is an opera singer. The dog does not need to be fed. So the two statements are written in positive statement. So the solution is Ellie Goulding is not an opera singer. The dog does not need to be fed. So here are another example. Write the following compound statement in symbolic form. Today is Friday and it's raining. It's not raining and I am going to a movie. If it's raining, then I am going to the basketball game. I am going to the basketball game or I am going to a movie. Another one, write each of the following symbolic statements in words. So solution A, the game will be shown on CBS and the game will be played in Atlanta. Letter B, the game will be shown on ESPN and the Mets are favored to win. C, the Mets are favored to win if and only if the game will not be played in Atlanta.
The truth value and the truth table. The truth value of a simple statement is either true, which is represented by T, or false, which is represented by F. For instance, if the statement "she loves to chase squirrels" is true, then the negative of the statement "she does not love to chase squirrels" is false. Now, if the statement is true, then its negation, not P, must be false. So we put F in the same row under the not P column. The truth value of a compound statement depends on the truth values of its simple statements and its connectives. Truth table is the table that shows the truth value of a compound statement for all possible truth values of its simple statements.
Hello everyone! We are here to discuss about quantifiers and negation. What is quantifiers? Quantifiers are words, expressions, or phrases that indicate the number of elements that a statement pertains to. In mathematical logic, there are two quantifiers. There exist and for all. In a statement, the word some and the phrases there exist and at least one are called existential quantifiers. It is used as prefix to assert the existence of something. It is usually denoted by the logical operator symbol, which, when used together with a predicate variable, is called an existential quantifier.
In a statement, the words none, no, all, and every are called universal quantifiers. The universal quantifiers none and no deny the existence of something, whereas the universal quantifiers all and every are used to assert that every element of a given set satisfies some condition. In mathematical logic, a universal quantification is a type of quantifier, a logical constant which is interpreted as given any or for all. It asserts that a predicate within the scope of a universal quantifier is true of every value of a predicate variable. What is negation? Sometimes in mathematics, it's important to determine what the opposite of a given mathematical statement is. This is usually referred to as negating a statement. One thing to keep in mind is that if a statement is true, then its negation is false. And if a statement is false, then its negation is true. Let's take a look at some of the most common negations.
Compound statement in symbolic form. A simple statement is convey one idea with no connecting words. Example, it is snowing. This is an example of simple statement. Next is, I wish I were out of door. This is an example of simple statement with no connecting words. So let's proceed to the compounds. Compound is a combination of two or more simple statements using connectives. Sample of connectives: and, or, if, then, if, and only if. Example of simple statement together are compounds connecting words the, it is snowing, and I wish I were out of door.
We typically use variable P and Q to denote preposition which will stand for an specified statement. We use different variables in mathematics like in algebra. X will represent or equivalent to a value of a number, and P in geometry is equivalent to a point, segment, and intersections. So, let's have the first statement, which is and statement or the conjunctions. If P and Q are two simple statements, then the compound statement P and Q is symbolized by this and can be read as P and Q. So, how do we use these connectives in symbolic form? Let's have these two sample statements. Statement P, it is after 5 p.m. Statement Q, they are working. So, how do we write these two simple statements into compound statement? So, let's have the first statement. It is after 5 p.m. and they are still working. So, we can write it in a symbolic form like this, P and Q. The second statement is, it is after 5 p.m. and they are not working. So, we can write it in a symbolic form, P and not Q. Or statement or the disjunction. Disjunction is compound statement form using seeing the inclusive are represented by the symbol like this. Thus, P and Q or both is symbolized by this, or we can read it as P or Q. So how do we use this connective in symbolic form? Let P and Q represent simple statement. Statement P, the bill receives majority approval. Statement Q, the bills become a law. So how can we write it in compound statement? First statement, the bill receives majority approval or the bill becomes a law. We can write it in symbolic form P or Q. The second statement is the bill receives majority approval or the bill does not become a law. We can write it in symbolic form P or not Q. So this is the way on how to use these connectives in creating compound statement into symbolic form.
If-then statement. If P then Q is symbolized by P and Q or conditional statement. So how do we use if the statement in compound statement? Let P and Q represent simple statement. Statement P. A person is a father. Statement Q. A person is a male. A. If a person is a father, then that person is a male. So the symbolic form of this is P then. B. If a person is not a male, then that person is not a father. So we can write it in symbolic form as not Q, then not P. Next, if and only if statement. By conditional statement are conditional statements that are true if the statement is still true. They are both true, but the other one is not necessarily true. Like for example, if a person is a father, then that person is a male. Is true. And if a person is a male, then that person is a father. That is necessarily true.
Conditional and biconditional. Conditional is a statement that can be written in the form if P then Q, where P and Q are sentences. It is not even necessary to state the antecedent or hypothesis before the consequent or conclusion. Every conditional statement can be stated in many equivalent forms. For instance, if I live in Boston, then I must live in Massachusetts. The statement could also be stated as, I must live in Massachusetts if I live in Boston. A conditional statement consists of two parts. The antecedent or hypothesis in the if clause and the consequent or conclusion in the then clause. For example, this is a statement. The number is an even number, provided that it is divisible by 2. If we arrange it in if P then Q form, this will be the result. If it is divisible by 2, then the number is an even number. It is divisible by 2 is the antecedent or hypothesis. The number is an even number is the consequent or conclusion. There are related conditionals that are based on a given conditional statement. They are converse, inverse, and contrapositive. Converse. A categorical or implicational statement is the result of reversing its two constituent statements. For the implication P implies Q, the converse is Q implies P. To form the converse of the conditional statement, simply interchange the antecedent or hypothesis and the consequent or conclusion. For example, if it rains, then they cancel school. The converse of if it rains, then they cancel school is if they cancel school, then it rains. So if you can see, pinagpalit lang yung position ng hypothesis and ng conclusion.
Inverse. It is a type of conditional sentence which is an immediate inference made from another conditional sentence, assumes the opposite of each of the original statements, and is notated, if not P, then not Q. Example, if it rains, then they cancel school. Inverse, if not P, then not Q. So the sentence will be, if it does not rain, then they do not cancel school. So inverse simply negate the sentence. It turns that if the converse is false, then inverse can be also false. Contrapositive occurs when you switch the hypothesis and the conclusion in a statement and negate both statements. For example, if it rains, then they cancel school. So, we can reverse and negate it into, if they do not cancel school, then it does not rain. So, in that statement, you actually interchange the hypothesis and the conclusion, and you're negating both hypothesis and the conclusion. So, if the conditional is true, contrapositive should be also true, because it has the same truth value.
Common forms of P implies Q. Every conditional statement P implies Q can be written in the following equivalent forms. If P, then Q. Every P is a Q. If P, Q, Q if P. P only if Q, Q provided that P. P implies Q. Q is a necessary condition for P. Not P or Q. P is a sufficient condition for Q.
Good day, everyone. The conditional statements. When a conditional statement and its converse are both true, the two statements may be combined. Is the phrase if and only if, sometimes abbreviated IFF. Example, conditional true. If two angles have the same measure, then they are congruent. Converse true. If two angles are congruent, then they have the same measure. Conditional. Two angles have the same measure if and only if they are congruent. The conditional statement, don't use if and then clause, and also the conditional statement is a true statement if and only if. The conditional statement and its converse are both true. So, meaning, ang biconditional ay magiging true lamang daw kung ang conditional statement at converse statement are both true. For example, this is a conditional statement. Conditional true. If two angles have the same measure, then they are congruent. Converse true. If two angles are congruent, then they have the same measure. Biconditional. Since both statements are true, we can go ahead and make our conditional statements. Biconditional. Two angles have the same measure if and only if they are congruent. Thank you.